Hello, welcome back. In the previous segment, we proved basic function property. If x is equal to y, we cannot conclude f of x is equal to f of y. Z3 was able to come up with a counterexample function f, but we did evaluate the function manually. I plugged in actual value of x, y, evaluated f of x, evaluated f of y to show you these two things are not equal. How about letting Z3 itself evaluate for us? Let's do that. So it's pretty similar to whatever I have shown previously, except I made some small changes in my prove routine. I will show you the prove it in a moment. The prove it function will give us a model in this case because we have proved that if x is equal to y, f of x need not be same as f of y. How do we actually evaluate the actual value for f of x and f of y? We can use Z3's model evaluation capability. Okay, so we get a model from prove it and we can evaluate the model at a particular x. Model.evaluate f of y, model.evaluate f of x. We can actually print the function itself using model of f. The model is just an array of all the symbolic variables we have, in this case x, y, and f. So we can print the concrete values. Okay, so it's very simple. Model.evaluate can be used to plug in the function that is coming from Z3 and we can get the concrete output. Yeah, you can see here, first line printed the function f because I did model.f, mapping 0 to 1, 1 to 2, anything else goes to 1. We talked about it in the previous segment. We got a concrete x and y that is equal to each other. Interestingly, you can see here f of x is evaluated to 2, f of y evaluated to 1. You can see for yourself that is the case. F of 0 is 1, f of 1 is 2, therefore you get 2 here, and therefore you get 1 here. Evaluate is a pretty nice capability built inside Z3. Let's look at the prove it function. The prove it itself is similar to what I have shown earlier. The counter of the theorem is not satisfied. That means this is always false. This whole thing is always false. That means the theorem must be true. In that case, there is no counterexample. Otherwise, there's a counterexample that's written by s.model. S is the solver object. I'm calling the prove it. In this case, I know this is wrong. Therefore, I get a model. And then I'm showing you the actual function x and y and evaluating it at f of x, evaluating it f of y. Okay, that's basically it. Thank you very much.